Hello, our most valued student. My name is Confident. Welcome to our revision session. And in this particular lesson, I'm looking at algebraic graphs. And this lesson is important for those of you guys who are doing your grade 12 mathematics, as well as those who are doing their mathematics N3 and N4. You will find these questions relevant. Sometimes you find it being asked in N3. They can even ask it in your N4 as well as your grade 12. So I took this actually from a previous paper. And let us look at this question here. As I said, it is algebraic graphs. So it involves calculus. And it is from a request on one of the students who said, can you please do algebraic graphs? So time and again, I will be doing you some algebraic graphs. And as I always say, guys, please send me your requests. If there is a section that you want me to cover, just put it on the comments and I'll be able, given time and chance, to look into that and then bring some lesson that can cover that section. So it is very important for you to leave some comments. And if this is your first time coming into this channel, I will encourage you to subscribe to our channel as well as to turn on that notification bell so that you are notified every time we post a new video. Without wasting time, let us dive into this section or into this question and see what it entails. Now let us look at the question. It says, example given, you are given that f of x is equal to 2x cubed minus 5x squared plus 4x. So this is what you are given on the question. And question number 1, you're supposed to calculate the coordinates of the turning point of f. So now, if they want you to find the coordinates of the turning point, so what I'll do is, let me have a new page where I can be writing this. So what I have is my f of x. As you can see, f of x is equal to 2x cubed. I can write that down to say my f of x is equal to 2x cubed minus 5x squared plus 4x. So now let's look at the first question again. This says calculate the coordinates of the turning point of f, and look at the mark allocation. This question is 5 marks just to find the coordinates of the turning point. Now when they are talking about turning point, you must remember this is calculus. You are supposed to find dy over dx. In other ways, you are finding, since they gave you f of x, you are finding f prime of x. So that is calculus to find dy over dx. So if I can then find, in this case, using the rules of differentiation, f prime x is equal to, I'm using the rules now, which is 2, and then I drop down the 3 of the cube, and then it will be x, 3 minus 1, I repeat again, minus 5, I drop down the 2 from the x squared, and then it's x, 2 minus 1, plus 4. Since it's only x, I put a 1 there. So these are the rules of differentiation that I'm using. So to do that, 2 times 3, I get my 6x squared as 3 minus 1. 5 times 2 is minus 10. 2 minus 1 is x, and then plus 4. So this is my first derivative, which is f prime x. Now the question was, I need to find the coordinates of the turning point. Now what you need to know at this stage is that when you're finding the turning point, you need to have that information to say at turning point TP, f prime x is equal to 0. That is very, very important to know, because that they will also give you a mark to say at turning point f prime x, that is dy over dx, is equal to 0. So what you do then, you then take that derivative, which is 6x squared minus 10x plus 4. We are saying at turning point that is equal to 0. And then your duty now is to solve for x in that particular part. So it's up to you how you want to solve for x. But sometimes what I quickly do, to avoid wasting time, some of course they factorize the common way of product sum where they put it in vectors. But sometimes if you want to quickly do it, you can just quickly use what is called the quadratic equation, which is x is equal to minus b, which is minus this is if I can write it quickly here, this is my a, this is my b, and that is my c. Use a pencil for that so that you can quickly enter that. Is minus 10 using the formula of the quadratic formula, plus or minus square root of minus 10, which is minus b squared, minus 10 squared, minus 4a is 6, c is 4, all over 2a6. Guys, there are many ways you could have done this, as I said. Now you will get two values of x. The first one is x is equal to, that's when you have to, as I said here, you have to use your calculator in this case. So let us quickly look at that. So to get the two values, there is minus 10 and then plus square root of negative 10 squared, that is that minus 4, my a is 6, my c is 4, and then I have to divide that by 2 into 6. This quickly gives you the answer. X is equal to 1, that's the first one, and the other one, x is equal to 2 over 3. So we've got x is equal to 1 or x is equal to 2 over 3. So I've got the two values of x. Now the question didn't want only the values of x. The question says calculate the coordinates. So when they're talking about coordinates, it means you have to find the x and the y values. So what you do is, once you get the x values, you must go to the original so that you can find the y values. So to find the y values, you take the two values of x to say when x is equal to 1. Now what is y? You take it to the original to say f of x, let me just write it again, is 2x cubed minus 5x squared plus 4x. Now we are saying f of 1. Remember, you must always go to the original. You must always take the values back to the original, which is 1 cubed minus 1 squared plus 1. And again, you just rely on your calculator. It will quickly give you the answer there, which is 1 cubed. It's not really a must here. It's 2. It's more like 2 minus 5. Just doing it so that you can see, plus 4. And the answer is 1 there. So it's like 2 minus 5 plus 4. That's why it's getting a 1 there. And then that is when x is equal to 1. And when you're writing it in coordinate form, remember they say the coordinates. So when x is 1, y is 1. So we're going to protect that to say that is the first coordinate. Let's go and look at the second coordinate. Is when x is equal to 2 over 3, because there are two values of x. Now f of 2 over 3 is equal to 2 over 3 squared. This one you need to be sensitive also so that you don't make errors. Minus 2 over 3. This was cubed. See, already I'm starting to make errors. Plus 2 over 3. As I say, it's very important for you to be sensitive in this when you're inputting those values. So it's 2 bracket, and then fraction is 2 over 3 cubed minus 5, and then its bracket, it's 2 over 3 squared plus 4, and it's 2 over 3. And then equal to, you're getting 28 over 27. So equal to 28 over 27. I think if we can, in a way, get the actual values, like here, this is 0, 0.67, and we can say 28 over 27 here, just to get an idea. What is this 28 over 27? It's 1,037, which is 1,03. Now, if I'm to write, though, the important part is to write the coordinates. So we're saying when x is 2 over 3, y is 28 over 27. So guys, this becomes the answer now, the coordinates. So these are the coordinates of the turning points. The question was here, calculate the coordinates of the turning point of f. So that's how you get your 5 marks. And then the next one says prove that the equation, from here, the same equation, 2x cubed. So I want to prove that 2x cubed minus 5x squared plus 4x has only one real root. So they want us to prove that. In other words, let's find the roots of this equation. And to find the roots of that equation, let me write the equation again. Remember, it was f of x is equal to 2x cubed minus 5x squared plus 4x. Let me just check there again. 2x cubed minus 5x squared plus 4x. So this is this. Now, when they want me to find the roots of the equation, now the word roots means I must find, in this case, solve. It's either I'm solving for x, that's one way, or when they talk about roots of the equation, what they're saying is the x-intercepts. These are the x-intercepts, and you know, in the x-intercepts, y is equal to 0. So in other ways, you're solving for x there. So what you do is you take that 2x cubed minus 5x squared plus 4x, and you equate it to 0. That's what you're doing in that case. Those are the roots. That is where the solution of the graph. So let me just give you an example. If I can draw a graph like this, the roots in this case, when they're saying the roots of the equation, they're talking about those points where the graph is cutting the x-axis. Those are the roots. That's what they mean when they're talking about the roots of the equation. But since we're not referring to that graph for now, let us continue. The question was here, prove that the equation that has only one real root. So that's what we want to prove. So when you continue, you have to solve for x. You can see x is common here. That is x. So I'm going to factorize x first. So x into 2x cubed. I'm left with 2x squared there because I'm taking out 1x minus 5x because I took out again 1x from x squared plus 4 is equal to 0. If I can take back, multiply, and expand, you go back to the original there. So that is what I'm doing. So you factorize x at x, and then you are going to say, first one, either the first x is equal to 0 or this bracket 2x squared minus 5x plus 4 is equal to 0. Again, on the second one, I've got a quadratic equation, and in the quadratic equation, like I did before, this is my a, my b, and my c. So I'm going to solve for x here to say x is equal to minus b. It's minus 5 plus or minus square root of minus 5 squared. Just do that. It's minus 5 squared minus 4a, which is 2, and c, which is 4, all over 2a. I think that I mean 2, and my a there is actually 2. So now let's solve for x. If I use again the calculator there, I will have in this particular minus 5 that to the positive square root of negative 5 squared minus 4a is 2 and c is 4 all over 2 and 2. We do that equal to, now you see it's giving me a math error, says error there. If I go back, the main reason why I'm getting an error is on the inside of that there is a square root of a negative. Let me show you where the error is. If I say square root of bracket negative 5 squared minus 4, 2 and 4, that's where I'm getting that negative. You see, still coming out. So which means if I enter what is just inside is minus 5 squared inside the square root minus 4, 2 and 4. If I just do that, I'm getting, in this case, minus 7. So here it is going to be minus minus. I don't have to put that plus, but it's 5 plus or minus square root of negative 7. I think that square root of negative 7 over 2 times 2 is 4. So now when you're given that, this is when you're having that, you're going to say therefore x is, let's go back to the, sorry about that, let's go back to the previous. The question says prove that the equation is only one real root. So here we are going to say x, therefore x is non-real, because when you've got a square root of a negative, these are non-real roots. So x is non-real. That is what you're concluding, because the question says prove that x has only one real solution. So if you look at this, it says prove that the equation is only one real root. And from this case, you can see that the only real root that you can find is x is equal to 0. And you can say x is equal to 0 is the only real root. So here you have indicated this is the only real root, and then you have indicated that this is non-real. That's what they're trying to pick, to say, are you able to see that? So that is how they wanted you to solve that. And then the next question says sketch the graph of f clearly. So we want to sketch this graph of f of x. Then it says clearly indicating the intercepts with the axis and the turning points. So now if I come here, just have a space here to say, if I'm to sketch, remember this is a rough sketch that you are going to be having. So if I just have a line like this, say I want to sketch this graph. So this is my y-axis, this is my x-axis. The first important point is my intercepts. So what you do, you come back in the beginning. The first one was this one in the intercepts. Remember, x is 1, y is 1. Okay, sorry, these are the turning points actually. So I don't have the x-intercept. I think I need to solve that. So when I'm solving the x-intercept, let me just check if I didn't find them here. Oh yes, we did actually. The question said there is no real root. So the first x-intercept, it was x is equal to 0, and the other ones, remember, they were non-real. So we did that. So I will have a point. First point I will have is here. When x is 0, y is 0. The other one was non-real. Now, the first part actually I could have done is, when I look at this kind of a graph, this f of x is 2x cubed minus 5x squared plus 4x, you need to know the shapes. So there are two shapes of a graph. When a is greater than 0, it's supposed to be like this. And then when a is less than 0, it's supposed to be like this. So you need to be like this to say. So you need to know what shape your graph is. So in this case, this is not the shape, because a, in this case, my a here I'm referring to is this 2. You can see 2 is greater than 0. So we expect the graph now to be this shape, because here a is equal to 2 which is greater than 0. Are you seeing that? So which means that that will be the shape of the graph. Let me just undo this. So that would be that. And let me undo some of the things here. I just wanted to show you. So since we know the shape of the graph and there is only one real root, which means it will only cut, this graph will only cut here. Now let us look at the turning points. There are two turning points. The turning point is x is 1, 1, and the other one is 2 over 3 and 28 over 7. Remember, we're looking at this 2 over 3 as 0, 0.67 and 28 over 7 is 1, 0.03. So let's start with the first one. X is 1, y is 1. Let's look at that to say, if I make this as 1 and I make that as 1, I will have my first turning point there. All right. And then the other one is x is 0, 6 and 1, 0.03. So when x is 0, 6 and 1, it's just somewhere there like this, like that. Just at that point is almost there. This is when x is 0, 6 like this, and y is 1.3 there, 1.03, so that is just similar to that part. Okay, but anyway, how do you draw this graph? Remember, it is going to cut once. So this is a graph that cuts once like that. When it reaches here, it turns, see that, then it goes down, and again it turns. So this is how this graph was going to look like. So it is turning and turning. Now the question was, remember the shape, as I said, it is positive, so it will shape that. And the question was here, sketch the graph of f clearly indicating the intercepts with the axis. So here we indicate that this is 0. Just indicating that that is 0 is still fine. You don't have to do much. That's the first part. And then it says clearly indicating the intercept with the axis and the turning points. Now you need to show your turning points. Now this turning point is 1, 1, and this turning point is 2 over 3, 28 over 27. That they are going to penalize you if you don't indicate that. Are you getting that? So that is that. And the next question here, let me see. So that is 3 marks. Question number 4 says, for which values of x will the graph of f be concave up? So now they are talking about concavity. Now to find the concave of the graph, what they are actually asking you here is for concave. Let me write this for concave. What you do is you are looking at the second derivative of x. Then after that, you're going to equate it to 0. And let me do that. Let's look at the first derivative. We said the first derivative was, this was the first derivative. So here, I just can work it from here. The second derivative, f prime x, is equal to, because I got the first derivative. The first derivative is this one, which is f prime x is 6x squared that I have here minus 10x plus 4. So second derivative is 6. You drop the 2, x, 2 minus 1 minus 10, which is equal to 12x minus 10. Now this point is called the point of inflection. So you can say at inflection, that point of inflection, which I'll show you, f prime x is equal to 0. Just like saying at turning point, f prime x is equal to 0. So now you have to solve for x. So if I just want to solve for x there, it's 2x, 12x minus 10 equal to 0. Let me use a different pen there. It's 12x minus 10 is equal to 0. So 12x is equal to 10 divided by 12 on both sides. So my x here will be equal to 5 over 6. I think that's what I'm having as my x. Now, what is 5 over 6? If I can just use that use as SD to say 5 over 6. Just to say what is that? It's 0, 0,833. So this is 0, 0,83. So that is the value of x, right? So now they said I need to find the values of x for which the graph is concave up. So now you can see that x is equal to 0, 0,3. So when I come here and look at the concave part of the graph, let me expand this. So what they are looking for when they're talking about the concave is where the graph is turning. So if I can draw a normal cubic graph to you, let's say I have a graph like this. So concave is where the graph is turning, that point. And at this point, the graph is turning from, because this is concave down. At that point, that's where the graph starts turning to show up. So the concave up is starting from here all the way to until the end, until infinity. So look at this. In these cubic graphs, there are two concaves. From here, if I go this direction, you can see it's more like shaping down. It's a concave down until the end. And then from here, it's a concave up until the end. If this graph was looking like this, then they ask you again about concave up or down. Look at this. From here, it's concave down. Actually, it starts from somewhere there. That is that point of inflection. So if they ask you about the point of inflection, there is that point where the graph is interchanging from going down, from going up to going down. So this is going down and this is going up. You see, that point is called the point of inflection. And we used f second derivative. Remember that. So now with that, this then becomes concave down. Actually, this one is concave, it's changing, it's concave up because it's going like this and it's going up. And this one is concave down. I think, correct that. This is concave down. This is concave up. Look at this. Because from here, the graph is turning to go up and here the graph is turning to go down. So remember that. So if I have used that information here, let me maintain it for now, and I want to interpret the same graph here. You can see that at this particular point here, that is where the graph will interchange, and for it to do concave up, you can see that this is the concave up that we're looking at. So in this case, from here we need to find that value of x, and they told us that value of x, it was 5 over 6. If you still remember, if I can just go back, when we solved it, we said x was 5 over 6. This is the line that we got, which was 0, 0,833. So if I can then go to that graph and identify that point 0, 0,8, hence I expanded to say 0, 0,8 is somewhere here. Are you seeing that? So here, that is where the graph will be concave up. So the values of x, you can see from here, that point, from this point until it continues. So what is that value? So for concave up, x, the answer, the x must be greater than 0. Actually, you can use the fraction. X must be greater than 5 over 6. That is the answer that they wanted there, for you to be able to say which part of the graph is concave up, because it is from that point that the graph, if I can show you, is from this point going all the way up. That is concave up. So So this is up and the opposite is down. And remember, this is our point of inflection where we found f prime of x. So guys, that is how we could have answered those questions, and I hope this was of benefit to you. Now remember guys, this was mainly for those who are doing their metric grade 12, or if you're also doing your N3, because N3 in some sections is more of equivalent to your grade 12, but also they ask it in your N4 because actually grade 12 is the N3 and N4, the bridge is grade 12. So you find that things that are in N3 and that are in N4 you can be examined in grade 12. So this is a very relevant question for those who are in that level. Now we've come to the end of our section. Please don't forget to subscribe to our channel and share it with your friends and colleagues. Thank you.